Hi all, welcome you all to this new video today. This video is going to be on the fluid power systems and industrial automation topic. So the first unit is gear pumps. The basic principles and hydraulic pumps are discussed in the unit 1, and I hope you will be following my previous lecture on the fluid power systems. So on the continuation part, today we are going to see about gear pumps. So before that, we let us just have a quick recap of the previous session. So the first image shows the Pascal's law. Pascal's law, all the hydraulic systems are operated on the Pascal's law. So we know the pressure applied on a confined fluid in a single direction is transmitted equally in all the directions. So that is a simple example that is going shown in the first image. Then in the second and third image, we are having other different types of pumps. Okay, so gear pumps, one of the simplest and most reliable hydraulic pumps is a gear pump. The gear pump is a positive displacement pump, and it means that it delivers a fixed quantity of fluid every revolution of the pump shaft. So gear pumps are commonly used in automotive engines, for machine tools and industrial hydraulic systems. And we are having an arrangement shown here, the gear pump arrangement. So in the arrangement, we'll be having one gear attached to the drive shaft, and the other gear is attached to the driven shaft. So the gear that is attached to the drive shaft is called as a prime mover, and the other one is a driven mover. Okay, based upon the different arrangements of gears, so we are having two different types of gear pumps. One is external gear pump, and the other one is internal gear pump. So in the first type of external gear pump, both the gear teeth will be meshing externally, and in the second internal type, the gear teeth will be meshing internally. So that is the simple concept. And another difference that can be shown is both the prime mover and the driven mover will be moving in the same direction for internal gear pumps, and both will be moving in different directions, opposite directions, for the external gear pump. Okay, now moving to the working principle of the gear pump. So we are having shown a small arrangement here. So in this arrangement, we are having two gears, and one side is a suction side and the other side is an discharge or delivery side. So it is mentioned as inlet and outlet. So one side the fluid is entering inside the pump, and the other side the fluid is exiting the pump. So the working principle is shown in four different stages here. So in the first stage, that is the suction stage, the gears begins to unmesh. So when the gears are unmeshed, it creates a vacuum here inside the casing. So when the vacuum is created, the fluid is moving inside the casing, the pump casing. So as the fluid enters and the prime mover and the driven mover rotates, so the fluid is getting trapped in between the meshes of the teeth and the casing. So the trapped fluid is traveling across the pump from the suction side to the discharge side. So in the discharge side, the gear teeth becomes to mesh. So when they mesh, the volume inside the casing gets reduced. As a result, we are getting a pressurized fluid as an output. So the pressurized fluid is sent through the discharge side. So this is explained here. So now let us take a closer look at the internal gear pump. So in this internal gear pump, we are having the internal gear, regular spur gear, and it is a crescent shaped seal is in the external housing. So that crescent seal plays a very major role here. So the fluid is going to be moving trapped along this seal. So this is the point where the fluid will be moving. So in one side the fluid is entering inside the casing, the other side the fluid is exiting. So we are shown all the four stages, that is very clearly shown in the figure here. Also the stages are mentioned here. So the fluid enters inside when the gears unmesh, and the fluid is traveling across the crescent seal, and the fluid is pressurized and it is moving to the discharge side. Okay, So now the performance parameters of the gear pumps are shown here. So a continuous pressure of 200 bars can be maintained, and all the commercial gear pumps they operate to the range of this. So pressure range of 10 to 100 bars. Then minimum operating speed ranges of 400 to 500 RPM can be maintained, and this maximum speed can go up to 3000 to 6000 RPM also. Then the theoretical discharge of the gear pump is given by the equation here. So QT discharge theoretical discharge QT is equal to VD, that is volumetric displacement, into N. So N is the number of revolutions. So that is shown here. Then we are having the graphs shown here. Flow, this is a speed curve, and the flow versus a pressure curve at constant pump speed. Okay, so that is shown here. Now, taking a look at the advantages and disadvantages of gear pumps. A major advantage includes that high speed operations, it has a high pressure capability, and the compact design can also be achieved. Relatively quiet operation is ensured for the gear pumps. Gear pumps also have no overall bearing loads, so it improves the reliability. However, they also have some limitations. It is also shown here. They do not tolerate solid contaminants, because when we have such certain particles, it will be stuck between the clearances. We have a very fixed end clearance. Then the internal gear pumps are limited to medium pressure applications only. It cannot be extended to high pressure. To conclude, gear pumps are simple, robust, and wide hydraulic pumps. So they are reliability and ease of operation and consistent flow makes them a fundamental component of fluid systems. So in every fluid system, we can see the gear pumps being used. So these are certain references listed here.